Hello, everyone. Welcome back to the Soil Food Web. Today's conversation is Bridging the Gap, Real-World Case Studies in the Future of Regenerative Soil Science with Dr. Mary Cole. I'm joined by my co-host, Dr. Carla Portugal. We're so happy to have you here today. Please let us know in the chat where you're calling in from. Always a joy to see how far these transmissions reach around the world. Mary, it's just such an honor to have you here, and we're really excited for today's conversation.
Thank
This is
you.
a continuation of the series that we've been running over the past few weeks. Last week we had From Chemicals to Biology, a real orchard transition story, tracking, I think, over 6 years, a transition from conventional orchard to regenerative using the soil food web approach. All of these replays are available on our website and on YouTube if you want to go find them. Before that, we had a conversation from compost to AI, all about growing and tracking the microbes your soil needs, which was a fascinating conversation, looking a lot at fungi and a lot at how technology can enhance the work that folks have been doing to use microscopy to understand soil ecology. Before that, we were talking about water and landscaping, Grow More with Less Water, a commercial landscape case study. So please check those out if you're curious, if you haven't seen them already. And with that, yeah, this webinar series is all about practical steps towards regenerative resilient systems. We're here convening people who have been really doing the work, doing the heavy lifting, showing people how to transition systems away from dependency on synthetic chemicals towards regenerate resilient approaches using biology as a way to accelerate and enhance productivity and all the forms that happens all over the world. So Carla, I'll pass it off to you.
Thank you, Evan. It's my honor and pleasure to introduce Dr. Mary Cole, an internationally recognized expert in mycology, plant pathology, and soil microbiology. Dr. Cole has dedicated her career to advocating for biological farming practices that regenerate soil health, reduce synthetic chemical use, and improve the long-term sustainability of Australian agriculture and the planet as well. Dr. Mary, welcome here. It's an honor to have you back. We're going to hear from
Thank
you,
you.
but in a few words, who is Dr. Mary Cole by Dr. Mary Cole?
Well, Mary Cole is was born in far north Queensland, has lived most of her life in and around southeast of Melbourne in Australia, in Bunurong Wurundjeri country of our great Kulin nation. I have had a passion since a 4-year-old when I was introduced to the soil by my dad and a dear old Aboriginal elder. And so it was absolutely, there was nothing else for me to do except to work with the soil through microbiology, through my career, PhD in plant pathology, Monash University, University of Melbourne, Charles Sturt University, and working with farmers. I was never interested in an academic career per se. I was interested in its ability to allow me to work with people who would then go out and become soil scientists or scientists in some way, with a passion for the biological paradigm. Uh, I'm still doing that. I'm still doing it with my lab. I will continue to do that. And I see these people around the world as my disciples because I run across them or I hear from them and they say, Mary, it's working. I'm doing it. I'm still doing it. Do you remember me? And well, when were you my student? Well, in 1994. And I said, well, do you mind if I don't remember you? But I'm absolutely delighted you've remembered what I've told you. I will continue to do that until, like Elaine, we're composts in the sky.
Thank you so much, Mary. I'm Dr. Carlo Portugal, your co-host for today. I'm currently Director of Science and Instructor at the Soil Food Web Foundation and also have my consultancy, and I work mainly in Oregon and few projects in Brazil. And I'm delighted to co-host this with Evan. Evan, tell us a little bit about you.
Hey everyone, I am the executive director of the Soil Food Web Foundation. I grew up in Connecticut on a farm that was a land that used to be my family's dairy farm back in the day. So I'm excited to talk about pasture grasses a little bit later today. But I've spent my career meandering between the worlds of human health and planetary health through permaculture and regenerative ag and looking at food as medicine and supply chains and working with farmers in a consulting capacity and developing, biological amendments and finding ways to bring fertility and vitality to living systems. And it was that journey that brought me to Elaine in the Soil Food Web School. And I'm just deeply honored to carry forward this legacy and to have the great privilege to meet folks like you, Mary, and to work with incredible beings like Carla, who just are brilliant lights, teaching others how to do this work.
Thank you, Evan. And today's topic, just to recap, we are finishing up the introductions. We're going to from Dr. Mary Cole for about 30 minutes. Then briefly, we're going to recap the Soil Food Web Foundation offerings. There are amazing new things there for you guys. And diving in discussion and audience Q&A. So please, while you listen from Mary, click on the Q&A to put your questions to her. Sammy is here. Thank you, Sammy, to helping us collecting all these questions to bring to the discussion later. And as always, interacting in the chat with your peers. I see you guys there, people from all around the globe. And Jean, email me. I see you. Let's keep talking, interacting, and that's how we build this beautiful community we have. Thank you so much, everyone, for being here.
Well, we wanted to kick it off just by honoring and celebrating you, Mary, for the award that you won last year, and wanted to ask you to share a little bit about with everyone about what that award was about and yeah, how that came to be. And I also wanted to ask you, you shared such beautiful stories earlier when we were preparing for this about your relationship with Elaine and some of your history with the Soil Food Web School. And so would love to hear anything you had to share about some of that history. And it's been a little while since we had you on the platform. So it's great to have you back sharing your
Thank
wisdom
you.
with the community.
Thank you. Well, yeah, 2025, I um, as AgriFutures is a peak body in Australia for basically anything agricultural. And they have these Rural Women's Awards that one can apply for. However, I am not one that applies for awards. And so it was quite a surprise when I found that my name had been put up by a colleague for this particular award. And then to go through the process of interviews, etc. And then to win was a real, it was an honor, but it also was a vindication for the sort of 45 years of work that I had done in soil, and you call it soil stewardship, and it really is because our First Nation people always talk about caring for country and getting rid of that arrogance of the human race and saying, we are just another animal on the planet and we don't have the right to destroy, but we do have the right to preserve. And so to have that work recognized for me was a vindication of what I had done. And so it was really important to me because over the years, when I first met Elaine, back in, I don't know, I can't remember, 2010, 2011 or thereabouts, she was in Australia and Gerhard Grasser, who is a consultant down here in Victoria, he felt that Elaine and I, given that we were a similar age and we were doing similar things on the opposite sides of the planets, we really should get together and see if we could collaborate. And so Elaine had a lab up in northern New South Wales, and so she came down to Victoria, and she was brought here to my lab, and what she didn't realize, she was blown away because she was using an old house up in Lismore. What she didn't realize that this is a full research laboratory here. It's a fully set up research laboratory. And so she was really impressed and also enjoyed the fact that we're on a farm. And so she actually stayed with us and we made compost, but we didn't make compost in the rings in her particular way. And so but by staying here, she and Alan, she was teaching Alan how to make a ring. So I can remember their very first ring they made. They did it chat through the day. And then Alan, we were sitting over dinner and Alan said, oh gosh, the temperature's going up. And do we have to turn it if it's in the middle of the night? And Elaine said, well, if it goes over 70, we're actually going to damage the biology. So yes, we're going to have to turn it. So Alan was up and down all night. And about 2:30, he said, the ring is up to 65 degrees. And I said, well, I don't want to know about it. You better go and get Elaine out of bed and go and turn your ring. I'm not going to help you. It's your problem. So then I did get up, and here's Elaine and Alan in their pajamas with wellies, gumboots on and coats on, turning this compost ring about 2:30 in the morning. So I quickly went back to bed so they didn't know that I had seen them. And then we got up and I was doing breakfast and I said, how did it go? And Elaine said, now, Alan, what you must remember is you set up your compost ring so it doesn't come to 70 degrees in the middle of the night. So now Alan's compost rings are all turned during the day. He's got it all worked out. But here's Elaine, these two people, in the middle of the night in pajamas, turning a compost ring. So the thing about the compost ring, we've done thousands of compost rings. But all of the visits with Elaine, some of them she stayed here, or some of them it was when we were talking up at Lismore or up at Dookie College, which is an agricultural college, part of Melbourne University. We had week-long courses that we were running. The days were always good and informative, and the students were wonderful. But the best parts of it for me were at night when we would go back to the staff motel and Elaine would say, your room or mine? And I said, well, you've got the Shiraz this night. It must be your room. I've got the nuts. So we'd get ready, go into our bedroom, and we'd sit on the bed, have the first glass of Shiraz, made on the property, as it so happened. Melbourne University had their own vineyard, so it was local wine. Sit down there, and then we'd talk through the day. And then we'd talk through things that had come up or questions that we had that were not always microbiological. Some of them are quite philosophical, because if you think about nature, nature is philosophical. If you really get into nature, there's a philosophy there that transcends all of these religions and things that are all man-made. There's a philosophy there that nature is eternal and that we have the absolute right to care for it. So we would have these, but then we would have these discussions, usually at about the second bottle of Shiraz, because by this time we were lying on the bed. And we had these disagreements about the fungal kingdom. Now, Elaine conceded after many, many discussions that I probably knew a little bit more about fungi than she did. And so there was never an argument. It was really deep discussion. And this is what I miss most about Elaine not being with us now. We're similar age. We're both left-handers. And as I said earlier, left-handers are the most brilliant people on the planet. So it was right that Elaine and I were leading the forefront of soil biology around the world. It was I miss her now because I don't have that person to talk with anymore. And I have all of you young people who are now, disciples of Elaine and of mine, who are doing all the right thing. But my kind of soulmate of my age has gone. But that doesn't mean to say that what we're wanting to do is going to change. It's going to go on and on, because more and more young people are now understanding and believing and have done the courses with me and with the Soil Food Web. And there's now a grassroots movement with mothers and families saying, why are my children so unwell? It's because they're in a toxic environment and we have to change that. But the thing about it is that we can change it. It can be changed. But how do we fight the chemical companies? How do we fight the inertia of the governments? So we can change it. And there's lots and lots of examples all the way around the world of how it can be done. And it's not difficult to do. And then you have people saying, oh, well, it can be done in a veggie garden. How can I do it on 10,000 hectares? Well, I've got farmers up in the Murchison area who are making compost tea in 30,000 litre vats, old vats from the wine industry. So recycle, circular economy, it can be done at scale. And I think that's what's important, that it can be done at scale and it can be done in a short time. If you consider um, biological time is in millions of years, but we actually can recover damaged land in a couple of years. So do you want me to go on with the slides?
Yeah, absolutely. Well, thank you for that. What a lovely way to kick us off today. And yeah, you want to tell everyone about what you plan to present today? You mentioned some case studies. I know you have a few to share.
Yes, well, what I've done is, I mean, there are a lot, but I think one of the things that keeps coming up all the time for me here in Australia with the farmers is weed management. And how can we control weeds if we don't use herbicides? How can we control weeds if we don't cultivate? Well, herbicides, particularly glyphosate, which is still allowed in Australia, which absolutely breaks my heart, it has an effect on the soil microbiology. So we're doing more damage than good. Ploughing has a major effect on the soil microbiology, but particularly on the mycorrhizal fungi. And mycorrhizal fungi have such an important role. I see them as the future biofertilizer to save the planet. So what I've decided to do is to show a few slides of weed management and why I think it's important, and how both in a vegetable garden and also in a broad acre fields, whatever grains or whatever happens to be soya beans or whatever happens to be grown, how you actually can manage a weedy species um, by just basically looking after the soil. So that's basically what I would like to talk about today. So if we go to the next slide, this is interesting. This is our property, and it's one of the south paddocks on our property, and we have them all. We have them all. All our property is surrounded by the tree belts that you can see in that bottom right hand photograph. So in this big project that I had with Sustainability Victoria, um, we brought in two waste streams that apparent at the present time are going to landfill. One is feedlot manure from the big commercial feedlots, and the other is what we call FOGO, which is the food organic, green organic, that comes from the urban council, like the urban street side collections. This was all dumped at our place, and we put it into mixes of sort of trying to get the right carbon to nitrogen ratio. And you can see on the left hand side some of the leftover residue of the compost piles. But if you have a look in the foreground, we don't have, there's a particular flatweed in our area called capeweed, and it's a flatweed. It grows very close to the soil surface. It has a yellow flower. It proliferates with huge seed, very viable seed bank. But when you kill it off, because what the government departments say, oh, if you've got capeweed, use glyphosate, you'll get rid of it. Yes, you do, and it leaves a great big bare patch because there's no grass growing under it. And so what comes back in but weedy species, because they're easy to grow. Well, we don't have any capeweed on our farm, and then we got rid of one of these, or used up one of these stacks of compost. And Alan came in and he said, come out and have a look at this. All of this capeweed has come out of the feedlot manure. And you can see that in that bottom left-hand, the left-hand side photograph. And so, wow, well, we don't want that. So what he did was make up a very fungal-dominated compost tea. And he made it up in a 1,000 liter vat. And he put a really heavy drench just onto that circle where you can see the capeweed. Now, if you come across to the bottom right-hand side, you can actually see the area where the capeweed was. There's a sort of a depression there, and there's kind of yellowing. And that area would be probably about, if I do it in feet, 30 feet, about 10 meters wide, 30 feet wide in diameter. That was 6 weeks after 2 applications of compost tea. Now, if you have a look at the top photograph, where you're looking, where you can see the house, that's about 10 or 12 weeks after 2 applications of compost tea. Now, what we noticed through the years when we've been working with our farm and getting rid of weedy species, very early we noticed very clearly that where there was a lot of weedy species, there was 2 things. There was a predominant bacterial population, and there was also a higher nitrogen in the form of nitrate, as opposed to nitrogen in the form of ammonia in these areas where there were weedy species. Now, I have other farmers that have a bracken fern, and they have blackberries, which is introduced into Australia. And these cover dozens of almost half-acre areas. They're huge. What can we do about them? Well, they get told to spray them out with Garlon and Grazon and glyphosate. No, you don't. What you do is you cut them down, or you burn them out in the first instance if you've got to, in desperation. Then you get a whole lot of good hay or mulch or compost, and you spread it all over, and then you get your cattle and you put a hot wire around it, and you put molasses on the compost or the hay, and you get your cattle or sheep to just eat all of that hay, poop and pee where they are, and then you take them off. And then if you've got to seed to grass, you may have to, but you'll probably find your perennial species will come through. Now, a weed or any plant, for it to be able to survive, must photosynthesize. So with these things like blackberries and capeweed and bracken or any sort of plant that you're wanting to get rid of, if you stop it from photosynthesizing, then the only energy it's got to grow has to come from the roots. And that's a limited store of energy. So in these places where I have farmers who have got blackberries, I say, as soon as they come through, just pull it out or cut it off. And then that plant has to then go back to the roots and get more energy from the roots to then get a leaf above the ground to photosynthesize. Cut it off. Same thing in your vegetable garden. As soon as it comes through, cut it off. And so what we've found, we have really great success in getting rid of weedy species, like brambles and blackberries and some of those woody species, simply by not letting them photosynthesize. And using the cattle to poop and pee and break up the surface. And so over a couple of years, we can get rid of brambles that are covering half an acre of soil, half an acre of land in a couple of years. And all you do is just keep managing the little ones that come through. With other species of other well, let's go back to vegetable gardens. With the vegetable garden, the weedy species come through. But if you have a look at those weedy species, many of those are forage plants. They're actually edible. So they're not problems at all. Harvest them and use them as forage plants. If you have a system where there's no chemicals, you can actually pick those so-called weeds and eat them. We use them in stir fries and salads. They're not a problem. And so the other thing, if you've got those things and you don't want to eat your weedy species that are in your vegetable garden, don't let them flower. Don't let them self-seed. Don't let them photosynthesize. You'll get rid of them. They'll go by themselves. The other thing that I want people to understand is what's a weed? A definition of a weed is usually, oh, it's a plant in the wrong place, is the most simple definition of a weed. Well, who said it's in the wrong place? No, nature's saying that that plant is in the right place, because you've got to look at these weedy species that grow really rapidly. They are primary colonizers. Nature has put them there to cover a bare space, because nature doesn't have bare land. Only human beings have bare land. So a bare space, what nature does is very rapidly, quick growing weeds come up and they protect the land surface. They protect the soil surface. They stop it from blowing away. They stop it from washing away. They're not problems. They are absolutely beneficial. The other thing that weedy species do, often they're very deep rooted. Some of them are deep rooted. And what they're doing is they're saying, oh, there's an element deficiency in your plant root zone. So I'm going to grow here and I'm going to bring those elements up from deep in the soil up into your root zone. So what do people do? They go and glyphosate them out instead of saying, oh my gosh, let's make a weed tea from them. Because if you make, what they're doing is bringing up that element that's missing from the soil into the root zone. So and it's up in their leaves, etc. So if you just leave the roots, because that's where the mycorrhizae are, don't disturb those, take the top off, make it into a weed tea, put it back over the patch of weeds. They might be nettles, for example. If you don't want to make soup and pesto out of them and you want to get rid of them, then make your weed tea and put it back over again. Now, logic will tell us that if we're putting that element from the weed tea back onto the area where that weed is growing because that element is missing, we're putting it back again. So what happens? The weedy species disappears, because we are now using the elements back in from the, so weeds must never be seen as a problem. They're telling us a story. They're nature's protection for the soil. So here we don't want capeweed in our pasture because it contaminates our grassy species, our mixed species. So what do? We use compost tea. We use the diversity, because if you have a look, I didn't do it, but I know if I'd gone and taken some soil from under that weedy area, then there would have been a bacterial domination. What we've done by putting on a fungal dominated compost tea is we've shifted the soil balance back to a fungal domination. And we've probably, although I didn't measure it again, but I have in the past, we would have shifted the nitrogen in the nitrate form, which is there now, back to a predominance of nitrogen in the ammonium form, which is what perennial plants prefer. So nature's doing it all there for us. And this is one example of if you're in Australia or any country that has a flatweed, then make a fungal dominated compost tea and feed it and change the biological activity ratio diversity in the soil, and you won't have to put a herbicide on your property ever. And so there's a perfect example of it. The bottom photograph is about 6 weeks. The top photograph is about 12 weeks. I think I can see maybe 1 or 2 capeweed plants in that top one. They'll get pulled out. But all of that capeweed there has not been allowed to flower. It has now gone. It's disappeared. So let's go to the next slide. This is a winery that's just north of the highway from where I live. And the people who owned the winery, they came down and they did one of my workshops. But before they got themselves set up, they would buy their compost tea from us and take it up, because what I wanted the vigneron to do was, when he pruned, to put a heavy drench of a really fungal dominated compost tea onto the vine structure, but particularly running down the trunk and on into the vine row to kill off any of the sort of pathogen spores that may have been there. So, and so he took 600 liters up, because that was the size of our tank, took our tractor and our equipment up over the highway, up the road, up to his vineyard, and put it out. Now, some weeks later, I got a phone call. "Hello, Patrick. You didn't tell me about capeweed." I said, "Well, no, because you didn't ask me about capeweed." He said, "Can you come up to the vineyard?" And I said, "Yeah, okay." So I hopped in the car. It's only 5 minutes away, and I drove up. And we got into the truck, went up to the vineyard, and I said, "Oh gosh, that's looking good. Good green mid-row there, really nice. The vines look good." He said, "Well, what about the capeweed?" And I said, "Well, there isn't any capeweed." He said, "But have a look at the headlands." So if you have a look at the left-hand photograph, you can see the capeweed that's out beyond the vines. That's what we call the headland. Well, that it didn't have any compost tea. But if you have a look at that photograph on the left, at the end of where the posts are at the end, yes, yes, along there, you can see where he lifted the spray unit to go and turn around the corner. Now, can you see there is a difference in the green, and can you see there is no capeweed? So,
Oh yeah.
then, right, it's obvious. Then when you have a look on the right-hand side, you can see along the edge of the vine row, the road, yeah, there, no capeweed. Go to your left a little bit, loads of capeweed. Have a look at the one at the bottom. We're looking up and down the vine row, no capeweed. So he said, "What's happened?" And I said, "Well, we've changed the biological diversity of the soil." And he said, "But I only put 600 liters on 4 hectares. Now, I'm not sure how that converts to that's about 10 acres, 100 liters. It's only a few gallons. So it wasn't a heavy application." He said, "But that's one application." And I said, "It only needs one application if you do it properly. This is what nature will do for you." So then I said, "Okay, I wanted to talking an anecdote is okay. It's this. Show me the data. I'm a scientist. Show me the data." So I had a conference in Singapore to go to. So I took this data and I made a poster. And so on the next slide, I want you to have a look. What I did was I did two soil samples. I took one out in the headlands that didn't have any compost tea, and another soil sample inside the vine row where it had the compost tea. So if you have a look, what I did was I did our normal biological quantitative analysis of the soil, the active and total bacteria, the active and total fungi, the protozoa, and the mycorrhizal fungi, and particularly the active fungi to active bacteria ratio, which really is a good a sign of how balanced your soil is. Now, if you have a look at the no compost tea, the second from the bottom row, what we had was quite dry soil. We had not a lot of active bacteria. We had very little active fungi, and we had low levels of protozoa. So with low levels of protozoa, it means we're not getting the ingestion of the bacteria to release the plant available nitrogen. So our nitrogen levels also would have been low. Mycorrhizal fungi, it's low, but I mean it's not bad. He would be getting some good phosphorus from that. But the ratio of the fungi to the bacteria was pretty poor. We needed up around at the minimum of 5. So that's what we started with. And in that soil, there was loads of capeweed, um, big bare patches where the capeweed had died, very little vegetation in terms of grasses or useful growth. One application of compost tea. These samples were taken at the same time. So these were taken some weeks, well, when I went up and took the photographs. So it was some weeks after the application. So the soils were the same. So if you have a look then at the second, the sort of top, the second top one, you can already see there is a difference in the moisture content. Now it's only little, but there is a difference. If you have a look at your active bacteria, that hasn't really come up at all. The active total bacteria has come up a little bit, but we're not interested in bacteria because high bacteria drives weedy species. We're looking at a perennial crop, so we're wanting fungal domination. Have a look at how the active fungi has come up. We have a significant increase. And so there we're starting to get that changeover to the fungal domination. But have a look then at our flagellates and our amoeba. Big increase in population, which means where our nitrogen potential has increased enormously. These flagellates and amoeba require aerobic soil. But if you have a look at the ciliates can live in reduced oxygen. So they're a good sign of some sort of anaerobic conditions, whether they be compaction or flooding, too much water. If you have a look, we've actually reduced our ciliates, which is what we want to do, because it means we've got more aeration, we've got more activity, we've got more oxygen going through the soil. And even our mycorrhizal fungi increased a little bit. This is with one application of compost tea, but have a look at our active fungi to active bacteria ratio. What we've done, we've almost brought it up into the range where we want it to have good diversity and good activity and good nitrogen potential and good phosphorus uptake and calcium, etc. So what I'm trying to show you, this is in a vineyard with just one application of compost tea. This is what we can do by working with nature. If we then go and have a look at the pasture, which is the next slide, I think.
Before we move to the next slide, Mary, there is
Yes.
one question in the chat. People are wondering, what do you mean by DW in the second column of the, yeah. What are those numbers?
That's the dry weight. So if we have a look at the no compost tea, we've got 87%. So we've got 13% moisture in the soil. So if you just turn that into, make that say 80%, that's the degree of dryness. So we've got 13% moisture. But if you go to the next one, what's that? 22% moisture in the soil. So what we've done is we've increased our water holding capacity in the soil. So DW is dry weight. So it's just a way of saying, okay, 0.87 0.13. So 13% of that soil is moisture. In the other one with compost tea, 22% of that soil is moisture. Does that help?
Yeah, thank you.
Now this is our farm, and if you have a look at the picture on the left, you can see the grasses, and you can see where the fence line is, where our next door neighbors, dairy farmers, you would think they're commercial capeweed growers. It's just a carpet of yellow. Now, Alan puts out his compost tea, and if you look at the one on the bottom right, that's looking from their property back into our property with our beautiful Black Angus stock. Then have a look along the little one that's in the inset. These people have been on this farm as long as we have. And Alan gets very frustrated because we have to continue to clean our property because we have blow-in from all the flowers and seeds and things coming from our farmers. So if you have a look at that little inset, when Alan's putting out the compost tea, he goes out into their property about a yard, about a meter. And if you have a look along the fence line do you see? No Cape weed? Do you think they notice? Very frustrating. But here again is absolute proof. This property uses heavy synthetic input, NPK, urea. But by putting our compost tea along that fence line, just into their property, no Cape weed. Compost tea costs about, I don't know, 5 or 6 cents a litre. We can put out hundreds of litres for a couple of dollars. For them to put their chemicals on costs them thousands of dollars a year. And look what they've got. They're growing Cape weed. We have a few cents a litre onto our property. Look at our beautiful grasses. There's mixed herbage in there. You just can't see it from that photograph. But we have plantain and we have several of the other medicinal type plants in there. Chicory, all of those medicinal plants that animals will select if they have the opportunity when they want them as medicinal plants. So all our property has had, we've been here for 55 years, and so is the other property, 55 years, and all we've done is we've used rock dust, compost tea, and fish kelp and molasses. And we use a yeoman's plow, which simply drills into the soil and just opens it up. We don't plow our soil at all, never have. And this is what we can do. And this is probably my frustration with authorities, in that here is evidence at no cost. Well, next to no cost. Even if you add the cost of diesel in, given today's crazy world, it's still next to nothing compared with putting out NPK, which in effect doesn't work, because here's the proof that it doesn't work. So I find it very frustrating that I suppose farmers need to be given knowledge, and they need to be given evidence, and they need to be given courage, because every farmer knows their land very well. And I get very upset when I hear people talking about farmers trashing their land. No, they don't. They just don't understand. They don't have the knowledge. So we give them the knowledge and they want to do the right thing. And these sorts of things, these sorts of webinars that you put out, this is the evidence that for next to no cost, you can make a change. But it doesn't take 100 years to make a change. You can make a change in 2 or 3 years. It becomes more difficult with vegetable growers. But for broadacre pasture, it's not a problem. I have farmers up in northern Western Australia who are broadacre grain croppers. They now pasture crop, so they have a legume or something planted in between their pasture. They don't now plow up their soil. They cut their grain higher and leave stubble. They then go out with a good compost tea, fungal dominated compost tea, so that you can break down the stubble. You leave the roots where they are, because that's where your mycorrhizal fungi are. And so you don't plow it at all and break that up. You bring those all together and you work with them. And here's evidence, or here's lots of evidence of how you can do this without damaging your country. And what it comes back to is what our First Nation people here say: care for country, farm the soil. If you do both of those things, whatever happens above the soil will be the best it can be.
Brilliant.
Next one.
Mary, I'd love to ask you to expand on that a little bit more, especially in regards to the financial aspect. I think, the conversation has shifted over the years, and more we see people that are committed. They know if they grow regeneratively, the food will be no more nutrient dense. They want to buy organic. They want that. But there's still this perception out in the world that, well, we could do the right thing, but it's going to be way more expensive. We're financially stuck in the conventional way, and I
Okay.
know, but I'd love to hear from your experience. Could you tell people a little bit more about the reality of the sort of savings and benefits of doing things the right way?
Okay. Well, as part of my big research project, we worked with two farms. We worked with one that was a conventional input farm, and with our farm, which has not had synthetic chemistry for over 50 years. Um, and what we did was we went to the chemical companies and we said, please, will you give us prices to date of the various NPK mixes and urea mixes and lime, etc., that farmers would be putting onto their farm as on say a broadacre farm and also for a vegetable farm. So those figures were, and then we got our accountant to work out what it cost us to make our compost tea, our compost and our compost tea. So I can't remember their figures right down to the last dollar, but what we did was we looked at the various mixes of NPK and how much per hectare or per ton or per hectare they would cost. So for a perennial system, now a perennial system could be a vineyard or an orchard or a pasture like ours. The input costs, say 2 years ago, were between about $700 and $1,100 per hectare annually of input costs. If it was a vegetable farm, then those costs, equivalent costs, were between about $1,200 and $1,900 per hectare. Then when we come to compost and compost tea, what we did is we calculated the cost per litre of the compost tea, and it worked out at about 7 cents. Now, if we put out our compost tea at 150 litres per hectare, we're looking at $20. If we put it out on our vegetable patches at $250 per litre, we're looking at maybe what, $30 or $40, compared with between $800 and $2,000 for the conventional. Now then we'll say, okay, well we can't produce as much. Okay, in Australia, each one of our big organizations like the chicken industry or the wheat industry or the beef industry or the wine industry, their peak bodies know exactly how much NPK comes off per gallon, per kilo, per ton, whatever it happens to be, per liter. They know. All you have to do is go to those websites and you can get that information. So I say to my farmers, okay, we know what that figure is. All we have to do is produce more in our soil than you take off in your production. And we can do that. I could tell you about some farmers I worked with down in Gippsland and some farmers over in South Australia. They were so locked into the chemical paradigm that they were suicidal. And in Australia, a farmer suicides every 10 days. And that is a tragedy because Australian farmers are not, that we don't get subsidies. We don't get any protection really. And so this farmer was having to lease land to run his dry cows because he didn't have enough land to run his milking cows, plus his dry cows, plus his young stock. And he was so far in debt. He was just so far in debt, he could see no future. And so we said, well, why don't we look at, and I always say to my farmers, give me your worst paddock, not your best paddock, give me your worst paddock. Because if you lose production on that worst paddock, you're not losing anything because it's not giving you anything anyway. Give me your worst paddock. And so with those farmers down there, what we were able to do over 2 or 3 years, we were able to build their farm up biologically with using a yeoman's plow and fish and kelp and molasses and good compost tea. We were able to bring his property up such that he didn't have to lease another farm, because what he found was he was increasing the productivity in his cows. Therefore, he needed less cows because his productivity was actually going up, because his soil was going up. His cows were happy. They were spending a lot of time lying down, chewing their cuds like they were supposed to, instead of grazing all day on this grass that had no nutrients in it. So he had a future, and that was only over a period of 2 or 3 years. So he didn't have to lease more land. He didn't have to run so many cattle. He was able to go and take his children to football on Saturdays. And that's just one example of so many examples. In South Australia, I have farmers. I work with a company there that now make compost tea to my recipes. They send me photographs of a farmer before anything has happened, traditional NPK, urea, full of weeds, full of rushes, no real pasture. Okay, I give them a recipe. I have a look at this soil. I give them a recipe. The recipe goes on. The compost tea goes on. In 2 years, we've got photographs back. Beautiful pasture. Happy farmer. Time after time, this is what happens. Because what they're doing, and what they don't understand is when you add a lot of phosphorus, synthetic phosphorus, for example, the science now tells us, you hear a farmer saying, oh, I'm having to put more on every year. I'm having to put more lime on every year. Well, doesn't that tell you it's not working? Lime is terrible. Use your mycorrhizal fungi. Produce your calcium oxalate from your mycorrhizal fungi, and have the calcium where the roots of your plants actually need it. With the synthetic phosphorus, we're actually finding that it affects one of the biological pathways that actually leads to less health of the plants over time. So the biochemistry and the science is there. You just have to look for it. It's there. So with these applications of compost tea, we're shifting the biology to fungal domination, but we're actually also shifting the nitrogen availability from nitrate predominance to ammonium predominance. And that ratio of nitrate to ammonium ions in the nitrogen is really important in the quality of the pasture that you're actually going to get. Did that answer the question at all?
Oh, absolutely. Carla, did you have another question?
Yeah, it's a follow-up question on top of that, Mary. I think you touch a very good point. We still see a lot of farmers resistant to this regenerative approach. Besides all that you already told us, what else do you think that we, the new generations coming, can work to really open up the doors and let them give us a chance to show what we can do in Regen Ag system? How to kind of tone down this closed mindset, this afraid of losing yield, or I don't know if I can trust the system.
I think all we can do is show by example. If someone's in a conventional paradigm, they would never go and put on, X number of tons of NPK until they had a chemistry test done. When I say to farmers, oh, what would you come and have a biology test done, and then I can show you how to make that transition. I said, well, how can you do that? And I said, well, I can do that. I wouldn't offer it if I couldn't do it. Well, why do we have to know that? I said, but you don't go and put on synthetic chemistry without having a test or without knowing a little bit about your soil. Why would you go and do something else? There is an alternative. What is happening is the agronomists are through their education are just about almost completely 100% chemical based. Not there's some of them that aren't, but mostly chemical based. The big chemical companies and the stock feed and the companies that are in the various towns and villages that supply these chemicals, they are aggressive. I can tell you an example. PhD student. He finished his PhD. He went and got a job not very far from us because we're in a big agricultural area here. And he got a job because the farmer wanted to have an organic stream to his leafy greens and lettuces and small daily salad vegetables. So my ex-PhD student got a job. Some months later, he comes back and I'm sitting here at my desk as I seem to be glued to most days. And he walked in and I said, what are you doing here? And I said, why aren't you at work? And he said, I've lost my job. Oh, okay. Tell me about it. What happened? And this is the aggression. This is what chemical companies do. 2 chemical companies sent out representatives to the farmer. And they said, we will give you for free 2 agronomists, 1 from each company, if you will come back to using our chemicals. And the farmer did. So he sacked my ex-PhD student. That's one example of the power of the chemical companies. Another example is a farm down to the east of us. The farmer again was just great distress, financial distress, mental distress. He owed a huge account to the chemical company, and the chemical company said, that's okay, we'll give you 5 years to pay it off. Don't worry, we'll give you 5 years to pay it off, but you must keep buying chemicals. So he never got ahead. And this is what and Elaine related to this absolutely. Chemical companies are so powerful. They have so much money. If they want to do trials, they have the money to do trials. Those of us who are trying to do biological trials, we don't have the money to do the great big trials. And so it's really important that these sorts of small scale trials that you're doing over there and that you have data from your various people, like I'm showing here, pictures tell 1,000 words. But then when you put the data, like those two sets of data with them, you can't deny that. So I think, and so just coming back to how can we get the farmers have to have courage, and it takes a lot of courage. But I always say, just give me your worst paddock, not the rest of your farm, just give me your worst paddock. And then next year we'll do another paddock, and next year we'll do another paddock. But what is actually happening is I've got their worst paddocks because that's where I'm going to see the biggest response. And then I phone them up the next year and I said, right, you ready to do another paddock? Oh, we've done the whole farm. We got such a great response. I said, but what about my control paddock? I have to have a control paddock. The farm is all now biological. So it's a case, and then the farmers in the various areas, they become the spokesperson, they become the showcase. It's like our farm in our road here. When I have workshops, I say to people, did you have any problems finding our farm? Oh, for heaven's sake, Mary, it's so different from all the others. What are you talking about? And so I think this is what we have to do, and this is what we're doing, and we have people farmers all around Australia who are showing their farms as showcases, but it's getting the data, it's getting those figures like I showed you on those charts. It's one thing showing the picture. Okay, and they say, well, okay, as a scientist, I say, well, okay, so there's a difference. What does that mean? So what I try to do is to get the before and after application soils so that I can do those figures like you've seen in the that we showed earlier. And I think that's what we have to do. And farmers want to change. They desperately want to change. They just need to be given the data.
Brilliant.
Beautiful, Mary. Thank you so much. We can spend
So can we
hours here.
yeah, can we just have a look at the our farm here? Here's just go, this one. This is our farm. Now it's not as easy to get a good response because we've always been biological. So what I did was to get a soil that probably didn't have the 50 years of biology. What I did was I went to the street on the edge of the road under the fence line, and that was the closest I could get to what was probably a soil that didn't have a lot of compost tea. So if you have a look at the dry weight, you can see there was very little difference between the dry weight and otherwise. With the applications, or with no application, the figures were still not too bad, actually. I was surprised with the fungi. The protozoa were low, but because that was undisturbed, there was still some reasonable mycorrhizal fungi. But then we put our application on because we wanted to mimic what we did at the vineyard as well to do that. Very little difference in the moisture content. Bacteria were lower. Well, we don't want bacteria. Not a lot of change in the total bacteria. But the active fungi, by putting a fungal dominated compost tea, we were bringing our active fungi up and also our protozoa. The flagellates and the amoeba were coming up. The ciliates were going down because we were getting more aeration into the soil, more worm activity, and the mycorrhizal fungi went up. But what was really interesting was, and I noticed someone has noticed the bricks. When I have farmers bring their pastures, it's very rarely that I will get a Brix above 2, 3, maybe. But with the compost tea on our farm, just in the pasture, depending on the time of the year and how much moisture there is, we can get Brix of definitely up around 15 without any problems. Now, in our vegetable garden, we can get Brix of 18 to 23 in our kale, right? It's doable. It's absolutely doable. And this is a pasture. We only have a small property. We're only 60 acres. But these are one applications that I'm showing you, the change. And what we're actually seeing is the change in the fungal activity. And I'm going to have to get a drink of water. What I haven't got on this is the active fungi to active bacteria ratio. It's dropped off the end, unfortunately. But they're both the one at the bottom was about 7 in the range of 5 to 10. No, sorry, yeah, no, the range. 5 to 10, and then when we put the compost on, it was up around 7. So they were both actually in range, right? So as I say, our farm is probably not a good example because we've always been regenerative. But even with just an application of compost tea, you can see the response. And the one thing about our pastures, and our vegetables, as you increase the Brix, as you all know, as you increase the Brix, so you decrease the impact that pests and diseases have. But what you're doing is you're increasing the nutrient value. Now, if you have a look at the world literature, what they'll do is they'll measure in NPK. Well, there's not a lot of difference in those sorts of elements in fruits and vegetables between conventional, organic, and biological. But you don't buy your fruit and vegetables or grow your fruit and vegetables to get those elements, those nutrient elements. What you do is you buy them or grow them to get your antioxidants, your vitamins, your all of these sorts of things. Now, when you then compare conventionally grown fruits and vegetables or pastures or whatever with biological or regenerative or permaculture, however, whatever you want to call them, but anything other than synthetic chemistry, those antioxidants, those vitamins are orders of magnitude higher in our biological system than the conventional system. So if someone says to you, oh, you have a look at a paper, and there are a few papers out there that say there's no difference, but they're not measuring the right thing. If you measured the real things, your antioxidants, your vitamins, the difference is so significant that you wouldn't go and buy from a supermarket again, ever. And it's the same thing with the pasture. I have farmers coming to me for a workshop and they say, oh, gosh, Mary, you don't have much grass out there. Oh, what do you mean? We've got plenty of grass. Oh, well, no, we've just put our urea on and we've got this big growth of grass and the cows are up to their bellies. I said, okay, how long in the day do your cows spend eating? Oh, no, they're eating all day. I said, yeah, because they're starving. And elongation due to nitrogen is not giving you more nutrient, it's giving you more water and cellulose. I said, our cows go and feed for a couple of hours, then they go and find a nice warm spot or cool spot, depending on the weather, and they'll lie down for the rest of the day and chew their cuds because the nutrient value is in the little that they need to eat. So bigger is not better. More is not better. Elongation of and getting a bigger, taller grass is not giving you more nutrition. It's actually diluting the nutritional effect. So again, giving that, if we can get that data together with pictures, farmers want to know. And the young farmers that are coming through, or the young people coming through these days, they're educated. They've got degrees. They understand, even though they've been brainwashed with a chemical paradigm through the universities. If you give them the data, they understand the difference. And this is where we're getting those young people coming through into agriculture now. And what's really interesting, many of them are women, which is fantastic. It's taken 50 years, but it's women. They'll say, show me the data. So what we do is we show them the data. We provide them with the data, don't we? And then they know how to analyze that data. And they say, my gosh, okay, I can see that. I've got that. And that's what we're getting with the young people today. I've got that. That wasn't presented to me in my degree, but I've got that and I can understand the difference. And that's what we've got to do. And that's what's happening. It's happening slowly, but that's what's happening.
Absolutely brilliant. Well, thank you for sharing all that. Shall we go on to the next slide? You mentioned
Yep.
some of the studies and some of what's going on
Yeah,
in the
these are
research.
some papers. If people are wanting, these are peer reviewed. Now, I don't take information out of Google. All of the information that I take is out of Google Scholar. And I would put it to everyone, don't believe everything you see in Google, but go into Google Scholar where you'll find all the peer-reviewed papers. And these are just a couple, there's hundreds of them, but these are just a couple that are easy to access, that talk about the sort of influences that someone who is wanting to start off with could find very useful and interesting to read. That's the reason why I put those in there. So I'm not sure what the next slide is, if there is a next slide. Ah, yes. Oh, this is our compost workshop. Every 2 or 3 months, we hold a compost workshop. So on our farm, nothing is wasted. What we do is we pick up everything after, if there's been a storm or a big wind, Alan or one of our staff go out with the tractor and they pick up all the twigs and everything and they bring it back and it goes through a mulcher and we store it to make our compost because this is our carbon source. So again, this circularity is important. If it's organic, then it's able to be made into compost. It's able to go back to the soil as a compost or compost tea. So then when we're holding a workshop, what we're doing is we're wanting to make a fungal dominated compost because most of our compost goes to pastures and orchards and things like this. So you can see on the top right, we've got our carbon source, which is our browns, and we've got our nitrogen source, which is freshly mown grass. We don't use any manure in our compost. And there's no reason, because that's a good nitrogen source. But the reason why we don't use manure is we don't want to have to get into the sort of legal situation of having to test for pathogens like Salmonella and E. coli in particular. So we don't use any manure in our compost. It's all just plant material. And so if that stack there, if we get around 40% of green material and about 60% of our brown material, now our brown material can be mulch, it can be old plant material out of the garden, it can be cardboard with all the plastic taken off it, it can be egg cartons, it can be newspaper because the print now is safe. So anything that was ever from a biological source, we put into our brown stack. Then we mix it all together and we might put in some rock dust. There's a quarry nearby and we use rock dust, and our rock dust just happens to be 20% calcium. So we might put a cupful of rock dust into our cubic meter ring, which is about a ton of green material of plant material. Then we might put a cupful of a previous good compost pile in to seed with a lot of microbial activity. Then we might put in a little bit of fish and kelp and molasses. Maybe in a cubic meter ring we might put about half a cupful of kelp and fish and molasses. Mix it all in water and then pour it over when we're wetting down the stack. So then we have we make our ring, press it down, and it's there, and you can see the nice mix of green and brown. And we put a thermometer in the top. And normally what we do, depending on the time of the year, we put old bags from our chicken feed across the top to either stop it from drying out or the rain, getting too much rain through the stack. Put some bricks on the top, and we do that on a Saturday morning of the workshop. And I say to the people, on Sunday morning, have a look, because it could be, if we've been a little bit too excited with our nitrogen, we're going to have a stack ready to turn. So they come in, and so what do we start off with? Around about ambient, say between about 16 and 22 degrees. They come in the next morning and they say, oh, the stack's up to 43. And I say, already? Already? Okay, this afternoon, Sunday afternoon, you're going to have to turn that. Well, often it's Monday or Tuesday before it gets turned. But usually within 36 hours to 48 hours, oh no, maybe 48 to 96 hours of the first pile being made. Oh, sorry, yes, we do work with Celsius. I don't know how to convert. My apologies to those of you who are in Fahrenheit. Yes, we're in Celsius. What was I saying? Yeah, so after about 96 hours we turn, and usually within the first 7 to 10 days we've had at least three turns. And we try to keep it at around 60, 65, or 55 to 65 for 2 or 3 days, and if it's stable. But if it's still going up, then we do turn. But we try to keep it at around 2 or 3 days if we can, at around 55 to 65 degrees. Um, so then, after about 8 weeks, that ring is down to about half its volume. So what we say then is the temperature is going back to ambient at this stage. So most of the pasteurization, which is the heat generating part of making compost, most of the pasteurization is completed. But that's not compost. That is simply a pasteurized uh, raw materials. So what we do then is we then leave that where it is, make sure that it keeps aerated. So we're looking at the oxygen. We leave that where it is, or we take it out of the ring and put it somewhere, and we leave it for about another 12 weeks until we see all of that temperature has gone, and what we end up with is a beautiful black humus that smells good. That the earthworms have moved back in again. The protozoa have moved back in again, and then we store that in our bunker. And then when we want to use it, we simply put it through a sieve to take out all of the oversized stuff that hasn't, the sticks and things that haven't broken down, and they go back into the mulch pile for next time because they've also got extra microbiology on them. So they're just a cycle. So everything's circularity. Everything is circularity. Nothing goes out except the compost, which then goes out onto pastures or onto somebody's vineyard or somebody's vegetables or wherever it goes. And now people are really liking the quality of our compost so much that we're selling 100 kilograms every 6 weeks to big vegetable growers. And so now you can see on the bottom left here, we're having to increase our number of rings where we're making the compost. We don't we only make rings because we're making very carefully controlled compost for compost tea. And if you're going to go into a situation where you're going to take compost tea as the replacement for your synthetic fungicides, pesticides, whatever other sides you use, insecticides, then that compost tea must be very, very high quality. And this is the risk that the farmers feel they have problems taking. And I say to them, look, I'm not going to tell you how to run your property. I'm going to show you a better way. But what happens if you go over to a biological system, a regenerative system, whatever sort of permaculture system? If something happens that's going to give you an outbreak because of some weather event or because you're surrounded by other farms that have high disease load, if you get a disease load that you simply can't afford to lose your crop because of this, then use the softest of the synthetic chemistry. I'm not saying you are not allowed to use this ever again. I'm saying you do whatever you have to do to save your crop. It will rarely ever happen, but it might happen. But what has happened in the past, when this has happened to anyone, particularly my vineyards, when they get an outbreak of, say, a downy mildew or a powdery mildew, because they're surrounded by vineyards that are heavily into chemicals, I say, put your synthetic chemistry on. Get the softest one you can, put it on, clean up the mess. Have a look on the label rate. What is the residual time of that chemical? Often it's 7 days, 14 days, 21 days, whatever. As soon as that residual time has passed, drench your enterprise with a highly fungal dominated compost tea, drench it to runoff, and do it weekly. for 2 or 3 weeks. And that way you will replace your diversity, you will replace your beneficials back into your enterprise, but you have got rid of whatever that problem was, and your bank will be happy. Yeah. So Elaine used to say, you often have to take 1 step back to go 3 steps forward. We don't have the right to tell a farmer what to do. You must do this. No, what I say is, here is another way. Let us take a journey by starting with the worst paddock. If there is a situation that I've just described where you are going to lose your crop and you cannot afford to do that because of your relationship with your bank, then we go and find a soft option. We have a look at that withholding period. We then, as soon as that withholding period is gone, we then go in with our compost and compost tea and we fix up the problem. That little bit of damage, Mother Nature is very forgiving. She will help us come back because we've done the right thing most of the time. Is there another slide?
Oh,
Okay.
yeah, more.
Making compost tea. It's really, people say, oh gosh, I don't have time to make a whole lot of compost tea, or I've only got a small vegetable garden. That's okay. If you have a look on the top left, here's Alan. He's got a little 20-litre bucket. He's got a little piece of electrical quad, or whatever you call it, that's been heated and made into a circle, and the stopper on the end of it is actually one of those plugs that you put on the bottom of the legs of your chairs to stop them from scratching your floor. Yeah, nothing special. And then the holes are drilled into those circles there at the bottom, not at the top, at the bottom. And then we just put a fish tank pump on it, and we can make 20 litres of compost tea in 48 hours. And that compost tea, we can if we want to, we can dilute down, 4 or 5 times. So we started off with our little, this is our journey, our experimental journey, our 20-litre bucket. Then we went to one of our favorite hardware shops and we got a 150-litre container, which is the blue one, and then a 200-litre container, which is the green one, had our compost bag, and and you can see on the top of the green tank, the second picture, you can see a slightly bigger pump. So we go to a pump shop and we say, this is how much volume we've got, and we need to turn it over so we're keeping above 6 parts per million oxygen. Oh yes, you need this size pump. So we go buy that pump. And so now we're making 100 litres or 200 litres of compost tea. Very easy to do because it can be diluted down. Then when we got serious, we had a stainless steel tank, which is the bottom one. We had a stainless steel tank made, and that holds 1,000 litres. And so this is our big tank. If someone wants to buy 1,000 litres of compost tea, this is where we will make it. So, everything, you can start from 20 litres up to 1,000 litres, or my growers over in Western Australia that are buying the old winery vats and they're making 30,000 litres. It's all scalable. The other thing that I put in there is, now this is brewed. This is where you use compost and you feed it and you build up your populations of your microbiology. This is a brew. This is a compost tea. The leachate is simply, here again, we had an old drum, cut it in halves, make sure the plug's at the bottom, and it's got a cover on it, and we put compost into it. Then we put clean water in and we wash it. We stir it around and we wash it, and we wash the microbiology that's on the compost off into the water. And then we catch it at the bottom in a bucket. And that's a leachate. And you can use that when you if you're going to plant your veggies out, make some leachate up very quickly, put your plants into it and let them get all of that nice microbiology on before you plant them out in your veggie garden. Then you can use the leachate to just water them, and it helps them to get over the transplant shock. So you see, everything can be done in a little, but it also can be done at scale. And it can be as complex as you want it to be, or as simple as you want it to be. It's all doable. So I have people in older people in apartments, younger people in apartments, and so what they're doing is they're just making up a little bit of compost under the sink, and they're making a little bit of leachate, and they're growing their tomatoes or their lettuce in flower pots on their balconies. It's doable. It's all doable. Are there any others?
I think
Ah,
that's it.
beautiful, beautiful, Elaine.
What a brilliant presentation. Thank you so much for coming today and sharing your wisdom with us. We'll get to the questions and answers in a little bit. So if anyone has questions for Mary, please drop them in. This would be a great moment to get a sip of water, or a little break. We've got a few slides to run through, and then we'll get to the questions. But for all of you who are watching this, this is the point where we ask for your help and support in donating to the future of the Soil Food Web Foundation so we can continue to carry on this work. If you enjoy these webinars, our mission is to, educate, inspire, and train as many people as we can all around the world. And so those funds go to help promote scholarships, help us to create new programming, and all the other activities that we take on to carry forward this beautiful legacy. We're also really excited to announce that we have a new experience, a new platform that we've just launched that you can find at school.soilfoodweb.com. We're also making the courses mobily accessible, which will um, help a lot of people to access on the go. And we've got brand new and improved programs as well as all of the legacy programs that the Soil Food Web School is known for present on there. We've got a special for folks who have been following along and looking to jump in and are interested in pursuing a career or just skilling up in this work. So that's the foundation courses and the complete practicum, all of the theory and all of the guided practice with our brilliant team of mentors like Carla here, who will walk through how to implement this stuff. The soil microscopy, the biocomplete compost production, the liquid amendments, and wrapping that all together into a real field trial. So just like the case studies that you saw here today, you can learn how to put this all to practice in a real world environment. If you have any questions, reach out to our team at info@soilfoodweb.com. You can scan this QR code, and we've got a big discount as we're just now relaunching those advanced courses, the practicum courses with a really great iteration, a lot of work that's gone in by our team to put extra videos and extra lectures and extra support to help folks along that journey. Also, if you're not ready to dive in all the way, we've got a few free ways to engage. We've just launched a new community that's free for anyone who wants to join. So come meet other people from all around the world. We've got thousands of folks in there already. We've got students in 130 countries who, care about soil biology, are interested in regenerative agriculture, are practicing, at large scale or in their backyards or up on their apartment balconies. All are welcome, and we're excited to see you there. And if you've been curious about the foundation courses and Elaine's lectures, we're also for the first time offering sampling of 10 of those lectures from our flagship courses, the foundation courses, for free to anyone here. So catch that QR code and the discount code SPRING. And if you jump in, you'll get that as a free gift for attending this webinar today. And I think we've got an info session coming up next week. So if you're curious about these courses and wanting to learn more, a few of us at the school are going to be live to answer your questions, talk about the programs, kind of walk through in longer form end to end what we're offering and what's included in those programs. So please join us next week or catch the replay if you're interested. And if you have questions, just when you can't show up at that time, just send them in and we'll be sure to address them live during that session next week. The last thing I'll say running through this here is next month, June is Elaine's birthday month, and in honor and celebration of her life and the incredible impact that she had on so many of us, we're gonna have a lot of new activities. We're gonna be encouraging folks to come together and create ceremonial compost piles. We're gonna be giving away lots of scholarships to folks who are interested in taking the courses and wanting some financial support and just making as much noise we can about this beautiful work and yeah, that it works. It's been working. The solutions are here. We just have to choose to do things the right way. And as you said, Mary, care for our country and live in harmony with nature and give back to the earth as she gives so much to us and
Mm.
gives us everything that we have. So stay tuned for more on that. And with that, I will pass it off to Carla to open up the Q&A.
Thank you, Evan. Mary, thank you so much. There is so many layers of so many lessons here that's certain I will watch this webinar many more times because every time we're going to get a different one. So thank you so much for that. Evan,
Anytime.
I don't have control of this slide. Okay. So, Mary, in the chat, I saw a lot of discussion about the weed tea, and people got like excited on your definition of weed. But can you elaborate a bit more on what do you mean by weed tea? How do we see that, and how best to use a weed tea?
Right. A weed tea is it's again I have problems with calling these plants weeds because to me they're indicator plants, they're primary colonizers, but any plant that you don't want in a particular area, I suppose, is what a weed definition of a weed is, a plant it's not wanted or shouldn't be. But now, if you understand why that weed is there, then that definition it falls apart. But let's use nettles. Nettles are very common. They make beautiful pesto. They make fabulous soups, absolutely fabulous soups. You just have to wear gloves when you're picking them. That's all. But let's assume we have a nettle patch, and it's usually showing that there's a lot of fertility in that particular piece of soil. But if you want to get rid of the nettles, what you do is you harvest the nettles with good gloves on, and you just have a bucket of water, a clean water. Now, my definition of clean water is water that doesn't have the urban chlorine or fluoride or anything like that in it, and it's really rainwater or water that you've collected in a tank, but not from the reticulated system. And so all you do is you just put what I do is with if it's with nettles, I've certainly got gloves on. And what I do is I rub them and bruise the leaves and release the photosynthates out into the water. And then I just stir it around for a day or so, and you'll find the leaves become sort of a darker green, and they lose their sort of texture. That's okay. And then I simply take that water because that has all the nutrients that was in that plant. And these are all sorts of useful things like auxins and cytokinins and the elements, the chemical elements as well as antioxidants and all sorts of vitamins. And so I then pour that back over the plant if I want to get rid of that particular plant, or I use that as a nutrient source to water my vegetables with or my flowers. Now, the other thing that you can do with a weed tea is you can start it off the same way, but if you have a biological system, then one of the things that are also in your microbiological diversity are yeasts. Now, yeasts help fermentation. So if you then make your tea from your nettles, for example, and you stir it, but you let it go for several days, then you'll see it's starting to bubble. And so what's happening there is the natural yeasts that have come from the environment are now working on the sugars that are from the photosynthates that are in the nutrient that's come out into the water, and they're starting to ferment. So you can let that go as long as you want. You can let it go right through the fermentation process if you want to, or you can stop it anywhere you want. So what you're doing there is and then you can still use that in the same way as a foliar spray or a soil spray if you want to. However, but what you've got there is slightly different from the biochemical makeup of the tea prior to fermentation. But you've got different chemistry because everything's made of chemistry. That's why when I'm talking about fertilizers, I talk about synthetic chemistry. Everything is chemistry. What you've got is slightly different chemical makeup of a fermentation than you have of a fresh weed tea. Both of them are brilliant absolutely brilliant for your plants. And one of the things that I like the fermented teas for, and it doesn't make any difference, but I have a preference for fermented teas. If I'm planting out new plants, what I do is I just put them in a shallow container with the fermented tea, and I just sit them in there overnight before I plant them out. What I'm giving them is a whole lot of nutrients, but I'm giving them also the microbiology. Then I plant them out wherever, and then I use what's left of that tea to give them a foliar spray. And what I find is they don't get the same transplant shock. They set off and they start growing much more quickly than if you don't do that. So any tea is really simply taking the leaves of a plant that you feel you don't want, but now I'm hoping you've got a totally different attitude, because a lot of those weedy species are actually edible. They're actually forage plants. So I'm hoping that when you're not going to use that word weed anymore, you're going to call it, oh gosh, I've got a whole lot of pioneer plants. Oh my word, look what I've got here. It's a primary colonizer. That word weed goes out of the dictionary. But you can use them to make these teas by simply bruising and leaving them for different periods of time. And they're absolutely beautiful and so easy to use.
I love the idea of a pioneer tea. I think
Yes.
that's a great new term.
Yeah.
I know we've got
Yes.
a lot of questions. We're a bit over time, so we're
I'm
going to try
sorry.
and squeeze a few more in. We've got, some folks that are hanging out and I think eager to get their questions in. So, uh, Carla, I'll leave it to you for the next ones.
First, Mary, nothing to be sorry. We are just, I mean, thank you. That's the only
Yeah,
thing we have to say. Thank
I
you.
think we could be here for hours. Just
Yes, definitely.
lots
I'm
to talk
sorry I
about.
talk too much.
Oh, we
No,
love
no,
that.
just great. We really
So,
appreciate
yeah,
it.
Okay. Okay.
that's a
Compost to break.
very, yeah, go for it,
Yeah.
Mary.
Yeah. Compost to break down a thatch layer without needing to. Well, the thing about a thatch, if you don't penetrate, it does take a little bit longer. But what I like is I work a lot with golf courses. And what we use spikes. But if you don't want to do that, the thatch layer is simply telling you that the saprophytic fungi are not functioning sufficiently to break down the dead organic matter. So if you've got a thatch layer, particularly, I'm thinking now of the golf courses because that's where I'm trying to get rid of thatch, and we're doing that, and we've proven it. We've got data. We're doing that with fungal dominated compost tea. And if we have a heavy thatch, what we're doing is we don't dilute the compost tea. We put it on as it comes out of the brewer. So it's very concentrated. So we've got very high levels of saprophytic fungi. And we simply water that every week or every 2 weeks until we see, when we take a core, we can see that the thatch is no longer there. So it takes only a couple of weeks. On a steepish slope with thick moss layer. Moss and lichen, it's a little bit problematic there. It's a reason why it's there. If you have an area that has had heavy application of synthetic chemistry, what you'll find is the plants, the photosynthetic plants, not like grasses, they go away, and your moss and lichen layer cover the soil. And what they're doing is they're saying, "Oh my God, here's a bare piece of land. We can't allow this land to be washed away or blown away. We're going to cover it, i.e. lichens, i.e. moss, or algal layer." So it's nature's way of saying, you have damaged me, I need to protect myself, and I'm doing it with these. They're photosynthesizing. If you're wanting to get rid of them because there's been heavy synthetic chemistry input, go back to a highly fungal dominated compost tea. If you can spike, then all the better. But just think about the fact that moss and lichen are nature's way of protecting the soil surface, because the plant surface has the natural plants that were there before have been taken away, and nature does not like bare soil. So have a think about why they might be there. It's because you have an imbalance in your microbiology, or you have a buildup of synthetic chemistry in the soil. That's why you end up with mosses often in lawns, in gardens. I mean, lawns I hate. I think that's a waste of water in a country like Australia. But you can have moss in amongst the lawn. It's because your microbiology is incorrect. You've been putting on probably nitrogen to get a stimulation and a nice dark green grass. Stop doing that. Make a weed tea. Go find some weeds around your place and make a weed tea. If you can make compost and make a compost tea and get the saprophytic fungi, and they will then change the microbiology. And the lichens say, "Oh, well, you don't need me anymore." The moss says, "You don't need me anymore. I'll go back to sleep. Get on with it." So it's be very careful about why you're wanting to get rid of the moss or the lichen and why it's there. It's because the soil surface has been damaged. You can do it with a fungal dominated compost tea.
Excellent advice. Thank you, Mary. Um, Next question from Jean. Are you reapplying the biology at time intervals? Are there specific learning sequences that you recommend?
Yeah. So you're talking biology. I'm assuming you're talking about a good diverse compost tea, for example, or a compost. If you're starting out on the journey of regeneration, then you need to put compost tea out probably every couple of weeks. You'll never make enough compost to recover a property, because you need to put out 5 or 10 tons per hectare. Too much, maybe 2 or 3 tons per acre. It's too much. It's a lot of material. But if you make a very high quality compost tea, then you can put it out every couple of weeks. You'll find as you get the turnover and the microbial activity, and you can see that in your grass or the lack of weeds or whatever, then you increase the distance between it. We put out our compost tea now twice a year on this property, spring and autumn. That's all we need. So as you recover your soil, the distance between the time between your applications increases. But you can start off every week or two when you're starting off.
Sounds great.
Mary, this is a question from Alan, and I think that helps summarize a lot of what you told us today. When you mentioned the use of tea, which I presume is aerated brew extract, a lot of farmers in US are using extract, which is not brewed, just extracted from the compost in a relative short period. What
Yes.
are your
And
opinion on that
right.
versus tea?
Okay. Okay. The tea, as I explained, and as Alan understands, the tea is growing more microbes on the compost that you put in. An extract is extracting just those microbes that are on the compost that you've put in. Now, if you have a very, very good quality compost that you're using for your compost tea, that you're using for your extract, yes, this is fine. But the only difference is that between the tea and the extract is both of them you need really good quality compost. But remember that with your extract, you're simply taking off what's on your compost. So your compost has to be really, really, really good. There's no difference. But if I was using an extract, I would probably be putting it on. If I put on a tea twice a month, I would probably put an extract on 3 times a month. Because I know that I'm not getting the same concentration of, but absolutely, I have no problems with either. If it's just that you have the diversity, you don't have the population. That's all. Both are perfect.
Beautiful. Thank you. And we have the last question. Jean, that's an incredible question. I agree. How do you do that, Mary?
Oh, Jean, I have to. I have I have no other reason for living than to make sure that when I'm going to cry, when I leave the planet, like Elaine, our legacy is that we have some people here who understand that caring for country is really the greatest thing that you can do on this planet. So I will keep going as long as I have a breath in my body, caring for country, because I know that there are people like you in this audience who are listening and who feel as passionate as we four here do, that we have no other role on this planet, as far as I'm concerned, except to do good by the soil.
Thank you, Mary. I
Thank
can't
you.
think of any better words to end on. Thank you so much for your time and your decades of dedication to this work and to this cause and for sharing your brilliance with us here. Such an absolute honor and a pleasure. And I'm sure Elaine is smiling at all us right now.
She is.
And
She'd be saying, "Go get it, girl."
well, if you have any final words, I welcome you to share them. And I think to everyone who's watching, thank you for tuning in. And we'll see you next time. And Mary, we hope to have you back on the channel soon and to continue to
Would love
get
to.
some updates on the brilliant work that you're doing in this world. I know you're very busy and still running fast at
It's
making
my
this world a
pleasure.
better place.
Just everybody care for country. It's the greatest thing you can do, and it gives you the greatest pleasure is to walk out and see a tree smiling. So thank you, all of you.
Thank you, Mary. And thank you, everyone. I mean, there is, like Evan said, there is not much we can say besides thank you for another incredible, amazing, almost 2 hours that just flew by. And thank you, everyone. Remember that you can rewatch this incredible full course with Dr. Mary Cole in our YouTube channel pretty soon. And don't hesitate to contact us if you have any more questions.
Thanks, Clara. Bye bye, all.
Bye, everyone.
Bye. Thank you.